Now let us look at the second approach to solve exactly the same problem, and this approach will be using hashing. So we'll be using hash tables in this particular approach. Now what this approach is, let me just show you a brief introduction to the algorithm that we are going to use here. Now as you can see, it is one of the easiest way to solve this problem, and I can say that this is one of the most efficient way to solve this problem, because you can solve it by using order of n time by using this hash table. What do I mean to say by this? Assuming that this is an array. Now for simplicity purposes, I'm just going to assume some numbers from 0 to n, which are between 0 to n. So let us say the numbers are 0, 9, 1, 7, 2, 4, 3, 5, and let us say this other number is 6. We have these numbers, and this is the array A. Now as you can see, what is the range of these numbers? You can clearly see that these numbers are from 0 to 9. Hence, because these numbers, I mean the minimum number is 0 and the maximum number is 9. Now because these numbers are between 0 to 9, so we are going to create a hash table here. Hash table, this is the hash table, and for simplicity purposes, I'm just doing it just to explain what is this hash table and how we are going to solve this problem using the hash table. And we can assume much bigger numbers, a lot bigger numbers as compared to this, but I'm just trying to assume the simplest way to solve to show you how this algorithm is working. So we are going to take a hash table, and assuming that we are going to take the numbers between 0 to 9. So this is index location 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. So these are the total 9 index locations. Therefore, what we are going to do here is, we are going to take two pointers. First of all, the first pointer is going to be I. Okay. Now generally, when we say that we need a number x, this x can be anything. Let us say this x is 12. We need to find whether two numbers exist whose sum is equal to 12. Now what we can do is, we can take this number which is represented by I. For example, the first number which is represented by I is 0. So what we are going to do is, we are going to do x minus I, and then we are going to check whether this number exists inside this array or not. And to check this, we are going to use this hash table. Use the hash table. Okay, let me show you how we are going to use. So the first step is initialize the hash table with zeros. Initialize the hash table with all the values as 0. So it is 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. So we are going to initialize every index location here with the value 0. Now let me check the first value. See, this is going to be very interesting again. So let me check the first value. I is equal to 0. The first value is represented by I, which is equal to 0. So we are going to take 12 minus 0. Does this exist? Does this 12 number exist inside this hash table? No, it does not exist. So we are going to put that yes, 0 existed. So we are going to put 1 here. Okay. Now see, you'll get it. You'll get to understand this. Let me just take the second number. Now the second number here with I, which will be represented by I, will be 9. So what we are going to do is, we are going to take 12 minus 9. That is, we are going to get 3. Now we are going to go to the third index location because it is representing the number which is 3. And we are going to check this number 0. And if it is 1, if this value is 1, that means 3 exists inside this array. If this value is 0, that means 3 does not exist inside this array. Now initially I don't know whether 3 exists or not, even though it existed, but initially I'm just going to assume that it does not exist. So because we knew that 9 existed, so at the location 9 we are going to put 1. Okay, see how I'm going to make it easy, make it efficient. Now go to the third index location here. The third index location is 1. So I'm going to do 12 minus 1, which is equal to 11, and as you can see in the hash table, we have not created any location for 11. So at index location 1, I'm going to put this value as 1. Okay. Now increment the value of I. Again we have 7. So we are going to do 12 minus 7 is equal to 5. Now go to the index location 5. Now you can see this value is 0, right? So till now we know that 5 does not exist. So I'm going to go to the index location 7 and we are going to make it as 1. Again make 12 minus the next value is 2. So I'm going to do 12 minus 2, which is going to be 10. Now check whether 10 exists. We have not created any location for 10. So at index location 2, I'm going to make this value as 1. Again increment the value of I. Now we have 4, so we are going to do 12 minus 4, which is equal to 8. Now at the index location 8, we don't have 1, therefore we are going to put 1 in this location, and then increment the value of I, which is 3. So we are going to do 12 minus 3, which is equal to 9, and go to this location, and you can see at the 9th index location we have 1. Therefore we know that there exist two numbers, which is 9 plus 3 inside this array, whose sum is equal to 12. And this is very easy approach, and as you can see, it can be slightly a little bit tricky, but it is also very easy approach to solve this problem. Now as you have seen this entire approach, now can you find out the time complexity for this? So the first is we have to initialize a hash table. To initialize the hash table, it is going to take order of n time, because if let us say we have the numbers from 0 to n, right? The range is 0 to n. For example, here 0 and n is 9. So because if we have the range is 0 to n, therefore to initialize an empty hash table, it is going to take order of n time. Now for each element, now let us say there are k index locations from here to here. There are k index locations. This k can be less than or equal to n, okay, or it may be greater. Okay, so do the following, that we are going to find out this solution, or you can say we have to traverse this. In the worst case, we have to traverse this entire array at least once. In the worst case, that if there does not exist any number, then you have to traverse this entire array at least one. In that case, this is going to run order of k times. Therefore the solution here will be order of n plus order of k, which is equal to any one which is greater than, if n is greater than k, then the time complexity will be order of n. If k is greater than n, then the time complexity will be order of k. Therefore this is the second approach, which is by using the hash table, which is again a very easy approach to solve exactly the same problem. But as you can see, this is a much efficient solution as compared to every previous solution. Okay, so we have discussed three algorithms now. Number one, which is the naive approach, the basic approach, which takes order of n square time. The second approach, which using the sorting. Now with that approach, we are going to solve this problem at order of n log n time. And the third approach that we are using here is by using the hash tables, or you can say hashing, which is going to take order of n plus order of k time, which is most of the cases we are going to assume it as order of n, which is a much better solution to solve exactly the same problem. Now in the upcoming videos, let us write program for all these three approaches, and then we are practically going to compare them in terms of the time complexity which they are going to take to solve exactly the same problem. Okay, let us move on to the next video.